Another thing you can do for the ticket lock, right? One possibility would be, so what happens when you go to Costco, right? And you see that, again, I'm not sure how many you got on the optometrist, but they have a little thing you pull, and you see your number 152. And you hear them say, now serving customer 67. So you're 70 away. That's a good time to walk out to the food court and buy yourself a pizza, right? Well, probably, with your expectation of how quickly they're going to be handling people. So if you had some idea of that, then you could maybe not be sitting there looking at the current ticket number over and over and over and over again when you know there are 80 more to go. Right? So you can imagine some sort of a tuning where you maybe exponentially back off. So maybe what you do is you back off and you say, well, if we're 80 away, I'm going to look every so often. So I'm going to look and then maybe sleep a little bit, and look and sleep a little bit, or something like that. That's a possibility. Another possibility is you can do something like, let's say, we'll say, if you're the next person in line, you're going to keep looking at the current ticket number. That's fine. But no one else is allowed to look at the current ticket number, to spin on the current ticket number, only the next guy. And that would still mean a quick backup. That would still mean a quick handoff. But how then do we get the next guy to go? So what we could do is we could have something like this. So we could say the first guy, first in line, spins on the current ticket number. So we can have a hash of ticket numbers. So what we can say is the next guy spins on the current ticket number, and remainder spin on a value. We're going to have to, of course, make sure that our hash table, maybe each of our hash table entries is large enough so it's all in separate cache lines, because that's the whole goal of this, to make sure it's separate cache lines. So we'll have, let's say, an entry here, and an entry here, and an entry here, and these are all greater than one cache line, greater than or equal to one cache line. So what do we do when we come in and we add ourselves to the acquire? Right? We look, and then we go and we say, okay, what ticket number did we just get? Are we one more than the current ticket number? Okay, just go spin on the current ticket number. Otherwise, let's go ahead and hash our ticket number, and we're going to find a place to wait, and we'll start spinning on that. On a release, what happens? We have to do two things. We have to both, of course, unlock, so increment the current ticket number so that the next guy is going to wake up. The second thing we need to do, though, is we need to kind of wake up all the guys. We need to wake up the one that is 2 away. So if our current ticket number is 35, we know that the guy with ticket number 36 is waiting and spinning on here. But the guy waiting on 37 is somewhere in here. Let's say 37 is in here, right? Conceptually, it's in here. It's not actually stored in here. It is just looking, so spinning. And let's say this is a extremely simple hash table, right? So we just take the number mod 4. So 37, let's see, so this would be 0, 36. This would be 39, right, is spinning in here. Who else is spinning in here? Sorry, we're interested in 37. 37 is spinning here. It's correct that 39 is spinning here. Who else is spinning here? 40, 41, let's say, is spinning here too. So when we release 35, 35 is going to increment the current tick number. And what else is it going to do? And maybe in the opposite order, actually. It's going to also, definitely in the opposite order, it wants to wake these guys up. So it's going to increment the hash table at hash of 35 plus 2. That is, it knows 36 is immediately watching, and it knows 37 needs to wake up. 37, actually, I guess we do increment this ticket number. I suppose that's actually right. So it's going to increment this ticket number, and then when this guy wakes up and looks and says that this is now changed, it can then go look and say, well, what is the current ticket number? Well, the current ticket number is now 36. I'm the next guy in line. I'm going to go ahead and start spinning. 41 wakes up's not quite the right word, drops out of its spinning loop because this number has now changed. What the value is doesn't matter at all. It just changes from, I don't know, 6 to 7. We just keep incrementing. So it changes to 7, 41 looks, and 41 says, it doesn't care about this value at all. Remember, what it does is it just was an indication that it should now go look and see, oh, the current ticket number is now 36. I'm 41. I'm 5 away. I'm going to go back and keep spinning on this, waiting for it to change from 6. So our takeaways are really scalability is limited by however long the critical section is, right? Whatever the time limit of the critical section is affects how much parallelism can help. Scalable locks can avoid collapse, right? We saw this collapse because of the quadratic cost of handoff in times. And we're going to see in a later lecture algorithms that can avoid the contention altogether. All right, so we will look forward to seeing that.